Commutative and associative properties. Learning intentions. Learn the order rule, commutative, and grouping rule, associative. Use these rules with addition and multiplication. See they don't work for subtraction or division. Success criteria: I can. Swap numbers in addition or multiplication and get the same answer. Move brackets in addition or multiplication and get the same answer. Say if a statement is true or false and why. Properties of natural numbers. Commutative property. 3 plus 5 equals 5 plus 3. Shows that we can change the order in which two numbers are added without changing the result. Similarly, 7 times 8 equals 8 times 7. The examples above illustrate a very important property in mathematics, namely addition and multiplication are commutative. Addition of natural numbers is commutative. 3 plus 5 equals 5 plus 3. Multiplication of natural numbers is commutative. 3 times 5 is equal to 5 times 3. However, subtraction and division are not commutative, as illustrated by the following examples. 12 minus 8 equals 4, but 8 minus 12 equals minus 4. Therefore, 12 minus 8 does not equal 8 minus 12. 6 divided by 2 equals 3, but 2 divided by 6 equals 2/6, which is equal to a third. Therefore, 6 divided by 2 is not equal to 2 divided by 6. Subtraction of natural numbers is not commutative. 3 minus 5 is not equal to 5 minus 3. Division of natural numbers is not commutative. 3 divided by 5 is not equal to 5 divided by 3. Properties of natural numbers continued. Brackets. Brackets are used to prioritize part of a calculation. In every calculation, the part inside the brackets must be done first. This is following the order of operations or the bird mass rules that you would have learned in previous lessons. Consider 5 multiplied by 3 plus 4 is equal to 5 times 7, because 3 plus 4 is 7. We do what's inside the brackets first, and 5 times 7 is 35. However, if 5 times 3 plus 4 is equal to 15 plus 4, because 5 times 3 is 15, and we do what's inside the brackets first, 15 plus 4 is equal to 19. So we get a very different answer. Properties of natural numbers continued. So if we have 5 multiplied by 3 plus 4, so just focusing on what's on the left of the equal sign, 3 plus 4 is 7. So we would do what's inside the brackets first. So that would be 5 multiplied by 7, and 5 times 7 is 35. Now we can rewrite 5 times 3 plus 4 as 5 times 3 plus 5 times 4. 5 times 3 is 15, 5 times 4 is 20, and 15 plus 20 is 35. So we see we get the same answer. The statement 5 times 3 plus 4 is equal to 5 times 3 plus 5 times 4 illustrates that multiplication is distributive over addition. Similarly, for subtraction, 6 multiplied by 8 minus 5 is equal to 6 times 8 minus 6 times 5. So if we were to just focus on the left-hand side, 6 times 8 minus 5, well, 8 minus 5 is 3, and then 6 times 3 is 18. And then on the right-hand side, 6 times 8 is 48, and 6 times 5 is 30, and 48 minus 30 is 18. So we get the same answer. So we can see that 6 times 8 minus 5 is equal to 6 times 8 minus 6 times 5. So multiplication is distributive over addition. So 5 times 3 plus 4 is equal to 5 times 3 plus 5 times 4, which would give us 35. And multiplication is distributive over subtraction. So 5 times 6 minus 4 is equal to 5 times 6 minus 5 times 4, which would end up giving us 10. Properties of natural numbers continued. The associative property. To perform the operation 6 plus 8 plus 10, we could do it in either of these ways. We could say 6 plus 8 plus 10 is equal to 6 plus 8 plus 10. So doing the 6 plus 8 first, which is 14, and 14 plus 10 is 24. Or we could say 6 plus 8 plus 10 is equal to 6 plus bracket 8 plus 10. So doing what's inside the brackets first, 8 plus 10 is 18, and 6 plus 18 is 24. Similarly, 3 times 4 times 5, if we put the brackets around the 3 and the 4 and do the 3 times 4 first, which gives us 12, and 12 times 5 is 60. Or we could put the brackets around the 4 and the 5 and do 4 times 5 first, which is 20, and then 20 times 3 is still 60. So these examples illustrate the associative property of addition and multiplication, which states that the way in which the numbers are grouped does not change the result. So addition is associative. So 6 plus 8 plus 10 is equal to 6 plus 8 plus 10, which is equal to 24. And multiplication is associative. 6 times 8 times 10 is equal to 6 times 8 times 10, which is equal to 24. So it does not matter where the brackets go. Subtraction, however, is not associative. 10 minus 5 minus 4 is not equal to 10 minus 5 minus 4. So let's have a look at this in a bit more detail. So focusing on what's inside the brackets first. 10 minus 5 is 5, and then 5 minus 4 is 1. So on the left-hand side, we have 1. And then focusing again on what's inside the brackets, 5 minus 4 is 1, and 10 minus 1 is 9. So we can clearly see that 1 is not equal to 9. So putting in brackets does actually, and depending on where you put them in, does actually change the outcome. Likewise, division is not associative. So if we have 16 divided by 8 divided by 2, that is not equal to 16 divided by 8 divided by 2. So let's have a look. So focusing on what's inside the brackets first, 16 divided by 8 is 2, and 2 divided by 2 is 1. And then on the right-hand side, focusing on what's inside the brackets first, 8 divided by 2 is 4, and 16 divided by 4 is 4. And 1 is clearly not equal to 4. So with subtraction and division, where we put the brackets will change the outcome. Whereas with addition or subtraction or multiplication, it does not matter. Example 1. State whether each of the following is true or false. Part 1, 9 times 5 equals 5 times 9. Part 2, 10 divided by 5 equals 5 divided by 10. And part 3, 4 times 5 times 6 equals 4 times 5 times 6. So part 1, 9 times 5 equals 5 times 9. So is this true or false? It's true. 9 times 5 is 45, and 5 times 9 is also 45. So with multiplication, the order does not matter. Part 2. 10 divided by 5 equals 5 divided by 10. Is this true or false? This is false. 10 divided by 5 is 2, and 5 divided by 10 is a half, and they are clearly not equal. So with division, the order does matter. Part 3. 4 times 5 times 6 is equal to 4 times 5 times 6. Is this true or false? It's true. So focusing on what's inside the brackets first, 4 times 5 is 20, and 20 times 6 is 120. And then on the right-hand side, focusing on what's inside the brackets first, 5 times 6 is 30, and 4 times 30 is 120. Multiplying natural numbers. To multiply 20 by 26 using the distributive law, we proceed as follows. 26 can be broken down into 20 plus 6. So breaking the 26 into tens and units. Therefore, 20 times 26 is equal to 20 times 20 plus 6. So it's going to be 20 times 20 and then 20 times 6. And 20 times 20 is 400, and 20 times 6 is 120, and 400 plus 120 is 520. To multiply 32 by 47 using the distributive law, we proceed as follows. So 32 is broken down into 30 plus 2, and 47 is broken down into 40 plus 7, breaking each number into tens and units. Therefore, 32 times 47 is going to be the same thing as 30 plus 2 multiplied by 40 plus 7. So it's going to be 30 times 40 plus 7 plus 2 times 40 plus 7. So 30 times 40 plus 30 times 7 plus 2 times 40 plus 2 times 7, which gives us 1200 plus 210 plus 80 plus 14, which gives us 1504. Using the array method, it's much easier to see what's going on. So this is sometimes known as the box method or the array method. So if we want to do 32 multiplied by 47, we're going to break it into 4 boxes. So we have the 40 and the 7 representing 47 along the top. And we have the 30 and the 2 representing 32 along the side. So then we just multiply the different parts. So 30 times 40 gives us 1200. And then 30 times 7 gives us 210. And then 2 times 40 gives us 80. And then 2 times 7 gives us 14. And then we just add up the 4 parts. 1200 plus 210 plus 80 plus 14 gives 1504. So it's much clearer to see how we can work this out using the array method or the box method. It's a lot clearer and easier than this method here. But both methods are absolutely fine. So whichever method works for you, you should go with. We will be using these methods, both this one where we just use brackets and this one where we use the boxes, the array method. We will be using these again in the algebra chapter.